Hello students, we are going to study energy of the orbitals. Okay, that's how much energy the orbitals are consisting and what is the energy of the orbitals. Okay, so in this, what happens? We are going to study about degenerate ground state and excited state. Okay, so energy, if we are saying which quantum number determines the energy of the orbitals, it is the principal quantum number, isn't it? But if we are talking about hydrogen principal quantum number, it is okay, but rest there will be a difference there, and so we will be taking in that azimuthal quantum number also. Okay, rest other multi-electron atoms. Okay, now first, what is degenerate? Degenerate means consisting of same energy. Okay, like if we are talking about, okay, 2s, okay, is equal to 2p. It means what? This S and P, which is present in the subshells present in the second shell, are having same energy. Like 3S is equal to 3P is equal to 3D. Okay. Here also, what is there? They are having the same energy, and so they will be said to be what? Degenerate orbitals. Okay. Now, next we are studying what? Ground state. So if we are talking about ground state, what is ground state? हाँ, क्या होता है ये ground state? Okay, for hydrogen atom, if we are saying, okay, the ground state is what? This is the nucleus, only one electron. The ground state is what? 1s. Okay, but when we talk about the excited state of this hydrogen only, if we are taking, okay, suppose if this electron, if we are providing some energy, okay, then only it can happen. What will happen? It will move to the upper energy shell, that is the second energy shell. Okay, so here if it comes, okay, so what happens? Now this electron is said to be in what? The excited state of hydrogen, isn't it? Because it has entered what? 2s of this orbit, okay, isn't it? But it has to be present here. So here original place was 1s, but it has been moved on to, or it has been excited to the second shell, and so this is known as excited state, and this is known as the ground state. Okay. Now next, effective nuclear charge. Okay. First of all, what is nuclear charge? Okay. The protons are present in the nucleus, okay, the electrons are revolving, okay. Naturally, there is a force which pulls the electrons towards itself, that is the positive charge present in the nucleus, that is the proton, and this is what? Known as nuclear charge, isn't it? So, suppose, what is this? The nucleus, okay. I am explaining it with you an example, okay. This is the nucleus, okay. First shell, okay. Second, third. Now, I am asking you, if the electron is present over here and electron is present over here, whom it will attract most? The one which is nearer to it, okay. And then it will attract this and then this. So you can see now the charge of the nucleus is not same for this and this, okay, because here it is pulling it with more force and here bit less than this, and this is what known as effective nuclear charge. As we go on further with the orbits, what happens? This charge is different. Now, this I said to you with reference to the shell. Now I am going to say you with reference to the subshell. Okay, here I said to you what? It consists of, first one, it consists of 1s. Second, it consists of 2s and 2p. Third, it consists of 3s, 3p and 3d, isn't it? So here, now, what happens over here? You know the shapes of these subshells also. S is spherical in shape, P is dumbbell in shape, D is double dumbbell in shape. Their shape also plays a great role over here. Okay. Now you can see here what in this S, in one S the electrons are present, spherical in shape, probability finding of electrons same, naturally it will pull the electrons with the greater force. Coming to 2s and 2p, what happens in this with the effective nuclear charge? Here first what happens, the electrons present in the 2s will receive the force or will get the force of nuclear charge, and then what, the p. Okay. Likewise, when we go further, this effective nuclear charge, it will go on decreasing, isn't it? And why it is going on decreasing? We are seeing what? Here, this is only said what, screening effect. Here 1s, first it has got the or experienced the force of what? Effective, this nuclear charge. Okay, and then it passes on to the 2, and then 2s, and then it passes to 2p. Likewise, then it passes to 3s, and then it passes to 3p. Okay, naturally what happens at every stage, there is some screening of the of what, the nuclear charge, and this is known as what, screening effect or shielding effect. Okay, and this is how we can see how effective nuclear charge is experienced by the different electrons present in the different shells as well as the subshells. Now, for hydrogen, what happens? The energy of the orbital is equal to what? N. Okay, it consists of only one electron. But for the multi-electron, the energy is not equal to L. It is equal to N plus what? L. Okay, here we will be taking, I said to you earlier, principal quantum number also and azimuthal quantum number also. For hydrogen we have taken only N. Okay, but for multi-electron we will be taking N plus L. Now let us try to understand the table which is being made over here. Okay, first is representing the orbital, second is saying about the value of N. N means the principal quantum number. Third is saying about the value of L. It means value of azimuthal quantum number. And the last is N plus L, which tells about the energy of the orbital. Okay. So first, starting from the first, okay, 1 shell. Okay, value of N for that principal quantum number for this is what? 1. Energy shell is 1. But for S, the value of L is what? 0. Isn't it? So 0, here N plus N become what? 1 plus 0, that is 1. Okay. Coming to the second shell. It consists of 2 subshells, that is S and P. These all have been discussed in the earlier sections. Okay. So I'm not going so deep in that. If you are not able to understand where this 0 or 1 and these are coming, go back to this part of quantum number and just revise it and then go with this table. Okay. Now 2s and 2p consists what? The second, the shell, isn't it? So value of N for this becomes 2. Okay. Value of L over here. For S, value of L is what? 0. Value of P is what? 1. Now, for 2s, the energy will be 2 plus 0. Isn't it? It is 2. For 2p, it will be 2 plus 1, that is 3. So now you can see from here what is happening. You can see it, the energy is increasing. Come on, next to the second shell, third. Okay, it consists of what? S, P and D. Okay, so number of shells, this value of N you will write what? 3. But value of L will be what? 0 for S, 1 for P and 2 for D. Okay, now just 3 plus 0 got 3, 3 plus 1 got 4, 3 plus 2, how much did you get? 5. इतना ही मिलेगा ना? 3, 4 and 5. You are seeing what? Here also energy is increasing, but one thing you can see over here, that yes, 2p and 3s are having the same energy value, isn't it? So now, here, which will be written earlier? Okay, पहले कौन लिखा जाएगा? लिखा जाएगा 2p, उसके बाद ही 3s लिखा जाएगा, because the principal quantum number of 2p is less than 3s. ठीक है? अब चलो next shell में, which 4s, 4p and 4d and 4f, because from the fourth principal shell or quantum number, what happens, the f also starts. Okay, so now value of n here is everywhere what? 4, but value of L has the difference, that is 0, 1, 2 and 3, isn't it? Now here, come on, 4 plus 0, how much you are getting? 4. 4 plus 1, 5, 4 plus 2, 6 and 4 plus 3, 7. Now you can see the difference of the values of n plus L. 4, 5, 6, 7. Okay, here also it is increasing, but when you compare it with what? The third energy shell, here also you got 4 and here also you got 5, and this is the reason now you next section we will be studying about above principle, which has been arranged according to this table only, how the electrons are arranged in the different energy shells. Okay, so here if it is 4, which should be written first, this 4 or this 4? This will be written because the energy shell number is less, isn't it? But what happens in case of this? 4 will be written before this 5, which is what? 3D. So 4s comes before what? 3D. While we will be arranging in above principle in this next section. Okay. Next, we'll be dealing in the next class. Good day. Take care.